morning. We're going to be continuing on today with our multiplying whole numbers. Our learning target for today is I will be able to multiply 2-digit by 3-digit numbers. So we're going to start with a 2-digit by 2-digit and then move to this 3-digit by 2-digit. A couple vocabulary words I want to review first. Remember a factor. So these are words that we're going to be using this entire unit. So a factor times a factor is a product. A factor times a factor is a product. A factor times a factor is a product. And that's how you multiply. Like a dance I just made up. So a factor is the number that you are multiplying. So they're numbers you are multiplying. And then a product is the answer to a multiplication problem. So those are two vocabulary words that we're going to be using non-stop during this unit and really the rest of the year. So we got to make sure we know a factor is the number we're multiplying and a product is the answer to what we're multiplying. So I told you at the beginning of this unit that by the end of this unit you had to be able to multiply using the standard algorithm, which is the way that I learned in school, your parents learned in school, and they were probably really happy when they realized you're going to do it the real way. The old school way is what I call it, the old school way. So the standard algorithm is just the regular way of multiplying. But I am going to show you the standard way today, and I'm also going to show you another way because I want you to see why the standard way works. So what we do. Or what the standard way is really doing. So I'm going to start with a way that is not the standard way, and then I'm going to show you the standard way, and we're going to look and see how they're similar, where the numbers in the standard way come from. So let's start with 61 times 25. So I'm going to set it up first, stacked on top of one another. 61, actually, just kidding. No, I'm not for the first one. So I'm going to keep 61, and I'm going to multiply 61 2 times, and I'm going to tell you what I mean by that. Oh, I cannot write today. So I'm going to set one problem up for 61 times something, and I'm going to set another problem up for 61 times something. Now, I'm not just making the numbers that I want to multiply 61 up. They're not just like, ooh, this number looks good. And ooh, there's a 72 floating out there. I'm not just making numbers up. What I am doing is I'm looking at my second factor. So 25 is my second factor. And I'm going to break it apart by place value. Or I'm going to decompose it. So I'm going to decompose it or break it apart. So 25, if I decompose it by place value, like expanded form, it's funny how everything in math eventually ties in together. Interesting. So at 25, I'm going to break it apart by place value or expanded form, and it's 20 plus 5. So what I'm going to do to make it easier for me in my multiplication that I got going on is I'm going to do 61 times 20 first, and then I'm going to do 61 times 5. I'm still multiplying it by 25 because when I'm done, I'm going to take these two answers and I'm going to add them together. So I decompose 25 into 20 and 5. I'm going to multiply 61 by 20. Then I'm going to multiply it by 5. And then I'm going to put them back together. Because here I broke it apart. And to get my whole answer, I need to put it back together. So let's start with 61 times 5. So I'm going to start with my ones place, just like you do when you're adding. So 5 times 1 is 5. And then I'm going to go to my tens place and do 5 times 6. 5 times 6 is 30. So 61 times 5 is 305. Now I'm going to go to 61 times 20. Now we've done a lot of practice with this. I know that when my number ends in a 0 and one of my factors ends in a 0, my answer is going to end in 1, 0. So I'm going to go ahead and drop this 0 down, and then I'm going to ignore that 0. Because I put my 0 there, because just like when we estimated, we multiplied our whole numbers that weren't 0, and then we added all our zeros to the end. this is the same thing. I'm just putting my 0 first. So my 20 is in my tens place. So my answer needs to start in my tens place. So 0 needs to go in my ones place because I'm not multiplying by the ones place. I'm multiplying by the tens place. And we know that anytime we multiply by 10 or any multiple of 10, my answer ends in a 0. So I'm going to go ahead and put that 0 here, and then I'm done with it. And now I'm going to do 61 times 2. So 2 times 1 is 2, and 2 times 6 is 12. So 1,220. Now, neither one of these is the whole answer. Remember up here I broke it apart. I decomposed it. Well, now I have to put it back together. So I'm going to take these two answers, 305 plus 1,220, and I'm going to add them together. Add them up. 5 plus 0 is 5. 0 plus 2 is 2. 3 plus 2 is 5, and then I have a 1. So my final answer is 1,520. So that was called partial products. You broke them apart. You found a part of the product, two different parts, and then you put them together to find the entire product, the whole thing. So now let's just look at the standard algorithm. So what does that look like? And I want you to make an observation of, do you notice any similarities between partial products, what we just did, and the standard algorithm? So I'm going to set this problem up again, but this time I'm not going to decompose it. I'm not going to break it apart. I'm just going to keep it as 61 times 25. I'm going to ignore this 2 first, and I'm just going to multiply by the 5. So 5 times 1 is 5. 5 times 6 is 30. Now this is the biggest place that 5th graders, 12th graders, 35-year-olds, 70-year-olds, it doesn't matter. This is the biggest mistake that people make, especially when they're in a rush. So remember, when we talked over here multiplying by 20, what did we put in our ones place? We put a 0. Because we're not multiplying by 2, we're multiplying by 20. So we know our answer is going to end in a 0 because 20 ends in a 0. So over here, when you move to this 2, you're not multiplying by 2. What are you multiplying by? You're multiplying by 20. This is 2 tens. You're multiplying by 20. So because you're in the tens place, your answer needs to start in the tens place. So I need to put a 0 in my ones place. And I'm going to put a smiley face in that 0 because you remembered it. He gets left out so many times. People forget to put him. So he's really happy when people remember. So I'm going to put a smiley face in there. And I'll make him a little bolder so everybody can see him. He's a super happy 0. All right, so now I'm going to multiply. 2 times 1 is 2, and 2 times 6 is 12. And then I'm going to take these two numbers and I'm going to add them up. 5 plus 0, 0 plus 2, 3 plus 2. Oh, what I did over here. You guys were probably screaming at the computer, weren't you? Mrs. Sigmund, you got that wrong. 5 plus 0 is 5, not 0. I had multiplication in my brain. See, everybody makes mistakes. Everybody has those days. So my final answer is 1,525. So let's look at these. Do you notice anything about the partial products that we did here in the standard algorithm? Do you see any similarities? When I look at this, I see, well, when I did 61 times 5, I got 305. And I got 305 here. When I did 61 times this 20 here, not 2, but times 20, I got 1,220. And when I did 61 times 20 over here, I did 1,220. And then when I took both of my numbers and I added them up down here, I got the same answer as I did over here with the standard algorithm. It's the exact same thing. Partial products in the standard algorithm are the exact same thing. The reason that some people set it up this way and prefer partial products is because they always forget to add your happy zero. They forget to add that zero because you're not multiplying by the ones place, you're multiplying by the tens place. So they say, okay, well, if I go ahead and just break my place value apart and I see that zero, then I'll remember to put it. Over here, it's hard for me to remember to put it. That's what a lot of people will say. They like to do this way because they remember to put the zero. But if you look, it's the exact same. I did the exact same problems. I did 61 times 5 and 61 times 20, and then I added them together. But the standard algorithm just stacks it all on top of one another so that it's organized and in one place. So they're the exact same thing. One is just all together, and one decomposes them so you can see the place values that you're multiplying by. Either one of those ways is acceptable. At the end of the day, it's if you can solve your problem without using a calculator. Can you do it on paper or a whiteboard or a computer? Can you solve it correctly without a calculator? So either one of these methods will work because they're the same thing. All right, so let's try this 3-digit by this 2-digit. Sorry, dropped my erase stuff. All right, so I'm going to do the same thing to start with. I'm going to break it apart. So if I were to break 46 apart or decompose 46, I'm going to add that vocabulary word over here because that's a really important one. Decompose means to break a number apart. All right, so if I were to decompose 46 by the place value, what would that look like if it were expanded form? What would 46 look like in expanded form or decomposed? It would be 40 plus 6. Now, if I were to set this up as two different problems, like I did over here with the partial products, I would have 236 times 6, and then 236 times 40. And then I'm going to multiply, and then I'm going to put them back together. Since I broke them apart here, I got to put them back together at the end. So 6 times 6, 36. Carry my 3. 6 times 3 is 18. Plus 3 is 21. Carry my 2. 6 times 2 is 12. Plus 2 is 14. So 236 times 6 is 1,416. 236 times 40, so the same thing. I'm starting in my tens place. My answer, or my factor ends in a 0, so I'm going to go ahead and put my 0 in my answer and then ignore it. 4 times 6 is 24. Carry my 2. 4 times 3 is 12. Plus 2 is 14. Carry my 1. 4 times 2 is 8. Plus 1 is 9. 9,440. Now, remember I broke them apart to make multiplying easier for me. Now I'm going to put them back together. So I'm going to take my 1,416 and my 9,440, and I'm going to add them together. 6 plus 0 is 6. 4 plus 1 is 5. 4 plus 4 is 8. 9 plus 1 is 10. So my product is 10,856. Now, if I was a really good math teacher, I'm just mediocre, I would have told you to estimate before we got started. So I would have said, okay, let's round this to 200 times, I need to get rid of this blue marker. So I would have said, let's round 236 to 200, 46 to 50, 2 times 5 is 10, add your 3 zeros, and your estimate is 10,000. My answer, 10,856, is pretty close to 10,000, so I'm probably right. Unless I made a silly multiplication error, which we all know I can do because I made an addition error over there. We all do it. All right, so now I'm going to solve it using the standard algorithm. So remember, they're the same thing. One just separates them into two problems and puts them together. One keeps them together. So it's up to you how you want to do it. So I have 236 times 46. 6 times 6 is 36, carry my 3. 6 times 3 is 18, plus 3 is 21, carry my 2. 6 times 2 is 12, plus 2 is 14. We get the same answer? 1,416? We did. Now here's another reason that some people choose to decompose and then put them together. See all this carrying that you did? I carried my 200s and carried my 3 10s here. When you move on to the next place value, you have to remember to mark those off. You don't want to reuse them because they don't belong to your new problem. They belong to your old problem. So when you move on to your second place value, this 40, you need to mark off what you already carried because they belong to the 6. They don't belong to the 40. So make sure you mark that off so you don't accidentally add them in. All right, so again, I'm moving to my tens place, so I'm not multiplying by 4. I'm multiplying by 40. So I'm going to go ahead and put my happy 0 here. And then I'm going to, now I can multiply by 4 because I moved it over to the tens place. Now I can multiply by 4. 4 times 6 is 24. Carry my 2. See, that was a 3 before. Now it's a 2. So we could have made a big mistake if we didn't remember to mark that off. 4 times 3 is 12, plus 2 is 14. 4 times 2 is 8, plus 1 is 9. 9,440, 9,440. So we're good. Now I'm going to add these up just like I did over here. 6 plus 0 is 6. 4 plus 1 is 5. 4 plus 4 is 8. 9 plus 1 is 10. 10,856. I got it in both of my answers. All right, so either one of those methods is okay because they're really the same thing. They are the same thing. One you just keep stacked up. One you break apart and put them back together. So in your practice today, you're going to have 2 problems that you need to practice. There's a 2-digit times a 2-digit and a 3-digit times a 2-digit. You're required to answer, but you're also required to show me your work, what you did. So you can either do that on the whiteboard.fi, or if you have a whiteboard at home, you can do it on the whiteboard, take a picture of it, and upload it. Because I know some people are struggling with using the whiteboard.fi. So either use the whiteboard.fi, you can download it. If those black marks show up, then you can take a screenshot. And if you don't know how to screenshot, just Google how to take a screenshot on Google Chrome. It's like 3 buttons that you have to press. Or not on Google Chrome. How to do a screenshot on a Chromebook, and it'll pop up. Or you can do it on a regular whiteboard, take a picture of it, and upload it that way. So either one will work, but you must attach your work for both of those problems, and there's a spot for you to do that. All right, there are no small groups today because I have conferences with parents and I need to get everything ready. So no math small groups. There are reading small groups. So if you have a reading small group, I'll see you later today. If not, then have a great rest of the day. See ya. Bye.